To understand the atomic bomb, we must first understand the atom. The atom is composed of three main parts: neutrons, electrons, and protons. The neutrons and protons are located in the nucleus of the atom and hold the electrons in orbit. An element on the periodic table is signified by two numbers. The top number is the element's atomic mass, which is the masses of the neutrons and protons of the atom added together. An element on the periodic table is determined by the number of protons an atom has. If we change the number of neutrons, we get an isotope. Some of these isotopes are more stable than others. Uranium-235, for example, is unstable. These isotopes must undergo radioactive decay in order to return to a more stable state. There are three main types of radioactive decay: alpha, beta, and fission. These occur based upon an element's half-life, or the amount of time it takes for half of the amount of the substance to be depleted. Let's take a look at alpha decay. In alpha decay, the nucleus ejects 2 protons and 2 neutrons. Note that an entirely different element results from this radioactive decay process, and that this element is happy because it has returned to a more stable state. Beta decay is another radioactive process, and this is where a neutron from an atom becomes a proton and electron, and the remaining element is returned to a more stable state. Okay, and so the last type of radioactive decay that we really want to look at is induced fission. This is what we're most concerned with the atomic bomb. Scientists found that they didn't have to wait for the entire half-life of uranium specifically to be up. They found that they could just shoot slow-moving neutrons at the atom in order to split the atom into 2 parts. Lees-Meitner found that the 2 parts didn't quite add up to the original. So what does this mean? The laws of physics are broken? Actually, no. Einstein's theory of special relativity explains this phenomenon, although it's usually called E equals mc squared. This proves that mass does and can be transformed into energy, such as the case when uranium is bombarded by slow-moving neutrons. Most of these observations mainly had to do with uranium-235. This is because uranium-235 can undergo induced fission, along with plutonium, although we won't cover that here. Enrico Fermi, an Italian physicist who won the Nobel Prize for Physics in 1938, wondered if splitting the uranium atom could spark a chain reaction and produce an enormous amount of energy. He was correct in his assumptions and went on to work for the Manhattan Project during World War II alongside other famed scientists like Einstein. The fission process in U-235 takes 1 × 10 to the negative 11th seconds, which means that 40 billion fissions can occur in the time it takes you to blink. So, here we have the atomic bomb. There are 5 principal parts of the atomic bomb: the explosive charge, the U-235 bullet, the tamper, the U-235 sphere, and the barrel. The U-235 parts of the bomb must be created out of enriched U-235, which means that the sample must be 90% U-235. And these parts must stay separated until detonation, because the amount of U-235 must be at the subcritical level in order not to create a large chain reaction prematurely. When the bomb hits a certain altitude, the U-235 bullet shoots down the barrel into the core and spikes the neutron generator in the U-235 sphere, which emits alpha particles. These alpha particles react with beryllium-9, another element in the sphere, to create beryllium-8 and neutrons. These neutrons then produce the famed chain reaction within the U-235, but because scientists wanted as much U-235 to be fissioned as possible, a tamper was created. This tamper, created out of U-238, heats and expands while slowing the expansion of the core. Then, finally, the bomb explodes. The effects of an atomic bomb on a population are horrid. Some victims in Hiroshima, as seen in the clip, were vaporized instantly. Others had to deal with the aftermath: thermal burns, radiation poisoning, cataracts, infertility, birth defects, and cancer. Approximately 130,000 people died because of the act in Hiroshima, Japan on August 6, 1945, and not all of them died quickly. Illness occurs at a level of 1,000 rads, which is a unit of absorbed radiation. Hiroshima was doused with 10,300 rads. Its results: the corruption of the bone marrow, a drop in white blood cell count, anemia, bleeding, and the destruction of the stomach. over 10,000 rads, and the person will fall into a coma and will likely never resurface. At Ground Zero this man was found. His burns were extensive, and his waist remained unscathed only because a thick waistband protected it. This woman was found close to Ground Zero as well. Her white shirt deflected the heat and was thus not incinerated. The atomic bomb is a weapon of mass destruction. Its existence reeks of inhumanity and suffering. Ultimately, while the physics behind the weapon is a marvel, the destruction of human life is deplorable.